So what I have here is a parallel circuit. This is actually two branches. I have R1 and R2. So when you look at a circuit like this, you have to decide to yourself, okay, how do I know this is going to be a parallel circuit? That's the big question. The proper answer to that is to look at what we call nodes. So if I look at this point right here, node A, and I look at them, let me blow this up a little bit here. There we go. Point A, we know that this whole entire line, this entire row right here is point A. So at this point is point A, this point is point A. So we can say this is a rail. So we can say this top rail is our positive. So this is a rail, and we call it the positive because all these points are the same point and it's connected to the positive. Likewise, we can say point B down here is connected to all these point B's. So we can say this is our negative rail. This is our negative rail. So by looking at this, we know that if these two resistors right here, these two loads right here, are connected to the top and the bottom at the same points, then we know this is a parallel circuit. So this is definitely a parallel circuit. Good. So we got that out of the way. So what we could call R1 is we could call this R1 is we're going to call that branch 1. And R2 is equal to branch 2. So if we have multiple branches in our circuits, there's a couple unique things that happen to the circuit itself. So a couple of facts behind a parallel circuit. So number one, that the total voltage is the same for each branch. For each branch. That means that VR1 is equal to VR2, which is going to be equal to 10 volts. Number two, total current will increase as we add more branches. So we can say that in this case, IR1 plus IR2 is going to be equal to I total. Well, isn't that Kirchhoff's? This is going to be Kirchhoff's current law, which states that the summation of all branch currents subtracted from I total should equal to about 0, similar to Kirchhoff's voltage law. Number three, total power is the sum of all branch powers. So that says that PR1 plus PR2 is equal to P total. Finally, number four, and there's other interesting characteristics of parallel circuit, but I think this gives you a foundation of what we're looking for. Our total is not just the summation of the branches, but there's a couple of equations we have to actually get in order to get our total. There's many ways to find our total, but the equation for our total, if you're looking to use just the branch resistances, R1 and R2, if you have two resistors, then we have R1 times R2 over R1 plus R2. Or you could do the inverse relationships of it. This would be 1 over, and then the reciprocals of 1 over R1 plus 1 over R2. Now, if you have multiple branches, This one only right here is for two resistors or two loads. Likewise, when we look at this equation right here, we actually could do is we can have 1 over R1 plus 1 over R2 plus 1 over Rx dot dot dot, meaning that as I have more branches, I just have to have it's the reciprocals of it. Remember, this is 1 over, this part right here is 1 over R1, 1 over R2, 1 over Rx. Rx represents any of the loads we have, is actually the conductances. And then what we do is we invert the conductance to get a whole number. So going back to our circuit up here, we know that current is going to flow positive and negative, so we're going to have two currents coming through here. We'll call this IR1, and we'll call this IR2. We know that based on some of the things we discussed already, as we have voltage that's going to go across this R1 resistor, as well as R2 resistor, our currents are there's going to be a certain amount of current, and the summation of these two currents will equal I total. So that's what I'm going to talk about next in the next part.